Assalamualaikum students. I hope you are fine. आज का हमारा टॉपिक है लॉज ऑफ एक्सपोनेंट। लॉज ऑफ एक्सपोनेंट जो है अगली एक्सरसाइज के सम्स को करने के इनकी बहुत ज़्यादा इंपॉर्टेंस है। आज हम इन्हीं को डिस्कस करेंगे। तो पहला लॉ है हमारा लॉ ऑफ सम ऑफ पावर्स। लॉ ऑफ सम ऑफ पावर्स। इस लॉ की बेसिक स्टेटमेंट्स: in a product, if bases are same then the powers are added. So इसमें हम देख रहे हैं कि a बेस सेम है, इसलिए हम यहाँ पर पावर जो है वो ऐड कर देंगे। एग्जाम्पल भी साथ ही हम करेंगे ताकि हमें इसकी बेसिक समझ आ सके। 3 की पावर 2 मल्टीप्लाई 3 की पावर 5। सो ये हमारे पास वैल्यूज जो पावर में ऐड हो जाएंगी। 2 + 5 दैट इज इक्वल टू 3 की पावर 7। सो ये एप्लीकेशन थी इस लॉ की। लॉ ऑफ पावर लॉ ऑफ पावर। इस लॉ में इसकी बेसिक स्टेटमेंट्स कि पावर इज मल्टीप्लाइड। सो वी सी इन द राइट हैंड साइड m multiply n. So now we check the example. 3 की पावर 2 whole power 5. So we have 3 की power 2 multiply 5, that is 3 की power 10. Let's move to the next law, and that law is law of power of product. Law of power of product. In this law, we observe that the two values are in a product form having common power, and if we want to separate them, so it becomes a raised to power n multiply b raised to power n. So both the bases in the product will get the same power in the right hand side. So we check through an example. 3 multiply 2 whole power 5. So it becomes 3 की power 5 multiply 2 की power 5. Our fourth law of exponent which we frequently use, that is law of power of fraction. Law of power of fraction. In this law, the two variables are in the form of a fraction having common power. They can be separated in the right hand side acquiring the same power, a raised to power n, b raised to power n. We check this by an example. 3/5 raised to power 2. So 3 raised to power 2, 5 raised to power 2. Let's move to the next law number 5, and that is law of quotient of powers with same base. It has 4 different applications. It is used frequently in the next exercise, and we discuss one by one and understand with the help of examples. Let's begin with the part 1 of it, and that is we have same bases with different powers, in which we observe that the bases are taken as common, and the power in denominator that is taken to the numerator, because the power in numerator is greater than the power in denominator. And we should remember that the base should not be equal to 0, because if we put that 0 in denominator, and that will become undefined, indefinite, infinitive case. So let's discuss an example for it. If we have a raised to power 7 divided by a raised to power 3, and that will become equal to a raised to power 7 minus 3, that is a raised to power 4. Now we move to the next part of it, and that is a raised to power m over a raised to power n, that is equal to 1 over a raised to power n minus m. Why? Because the power in denominator is bigger than the power in numerator. So that is n is greater than m. Also a should not be equal to 0. Let's discuss it. An example for it. We have a raised to power 2 divided by a raised to power 6. What we get? Because the power in denominator that is greater than the power in numerator. So a raised to power 6 minus 2, it becomes the smaller power moved towards the larger one, bigger one, and we get 1 over a raised to power 4. Why we do this? The basic phenomena is that the power will remain positive. So now we will move to the part number 3 of this fifth law, and that is when the both powers are equal, and for this a raised to power 0 becomes equal to 1. Let's prove it. If we take a raised to power m over a raised to power n, that becomes equal to a raised to power 0. Why? Because m is equal to n. If we put these two equal values either in numerator or in denominator, we put in denominator, so it becomes a raised to power m divided by a raised to power m, that is a raised to power m minus m, and that becomes a raised to power 0. On the other hand, algebraically, we know that if we have a raised to power m over a raised to power m, both the values are same in numerator and denominator, they are cancelled, and hence we have 1. So from these two results, what we get? We get a raised to power 0 is equal to 1. So whenever we deal with such things, variable having power 0, that is, for example, x raised to power 0, that will be written as 1, 2 raised to power 0 is equal to 1, 5 raised to power 0 is equal to 1. So we put 1 when we deal with such values, such bases having power 0. Now we move to the part 4 of the fifth law of quotient of power is same base, and that part 4 is actually whenever we deal with a base having negative power, we have to make it positive. So it will be transformed as a raised to power 1 over a raised to power n. For example, 2 raised to power minus 3, it becomes 1 over 2 raised to power 3, that is 1 over 8 by the solution. Let's move to the second part of this fourth section, and that is if negative power present in denominator, so we will make it positive by doing this practice a raised to power n. For example, 1 over 3 raised to power minus 7, that will become 3 raised to power 7. So that's it for the laws of exponent.